seconds and go. So thanks for that. Thanks for the motivation. Awesome. Well, look, welcome to this live stream. Welcome to all the folks who are here on Crowdcast, and everyone who is watching on Twitter. I guess some people call it X, but I'm going to call it Twitter, or watching on LinkedIn. This is being multicast to a bunch of different places because we want to be wherever developers are, and developers are kind of scattered all over the place. So quick agenda. This conversation, and we'd love for this to be a conversation, and I'll talk more about that in a little bit. We're gonna spend some time talking about what is RAG. So this is a little bit of a RAG 101 talk. If you're a developer and you don't feel like you know what RAG is, or you don't feel super grounded in the topic, this is a fantastic stream for you to participate in. I want to be super clear that you don't need to have any machine learning or data science expertise or knowledge to sort of get value out of this conversation. In fact, we'll sort of learn about this later, but one of the things that's awesome about RAG is that it makes building AI applications accessible to all kinds of developers, all kinds of full stack developers, and it really removes the need to have deep expertise or experience with machine learning or data science. So we're going to talk a little bit about what is RAG. We're going to dive into LLMs, like what it looks like to work programmatically with an LLM without using RAG, and what it looks like to work with an LLM when you do use RAG, and like what's awesome about that. Then we're going to dive into RAG specifically using an open source product called Langflow, which is an awesome tool. It just makes it really fast and easy to build AI applications. And then we're going to turn it over to Q&A. So a couple bits of housekeeping for folks that are here on Crowdcast. If you haven't joined us on a Crowdcast live stream, welcome. Thank you for coming. If you've been here before, then this will be old news to you. But you'll notice that in the top right of your screen is a Q&A widget. So as we're going through today's live stream, if you have any questions about what we're talking about or concepts that we're discussing, please ask those questions in that Q&A widget, and we're going to monitor these questions as they come in. And you'll also notice that kind of like Reddit or Hacker News, you can vote up questions that you see. So like if you go to the Q&A widget and somebody has asked a question that you think is a great question and you would also like to know the answer to that question, please vote up that question. And we'll kind of see how it goes. Like we may get to some of these questions like in real time as the live stream is happening, and we will also have like a nice Q&A segment on the back end of this live stream, so we make sure to get through folks' questions. I wanted to remind everybody, because this question comes up a lot, like this live stream is being recorded, and it's going to be available for everybody publicly after the live stream is over. And we're going to send an email to everyone who joined us with a link to the recording of this live stream, along with like links to resources that we're sharing. Like we're going to show you guys a bunch of code notebooks, repos, like all the resources that we review like in this live stream. We'll make sure to share them as an email after the fact. So who is on this live stream? So we're going to go around the horn and introduce ourselves. And I have, in addition to sort of the basics, like, what's your name? Where do you live? What do you do? I always ask everyone who's on one of these streams kind of like a fun personal question. And David and Alex have not been given access to this. I've not told them what this question is. So they're going to be as surprised as you when I ask it. I'm going to have, so I'll go last. So I'm going to start with David. So like, obviously, like tell us maybe where you're located, what do you do? And then the fun getting to know David question for everybody is, are you a Marvel person or a DC person?
Ooh, Fun. Well, hello everybody, and again, thank you for joining. I'm David Jones Gilardi. I'm in Orlando, Florida, in the United States. So, for those of you who are not familiar with it, you may be familiar with Disney World or Universal, like all of the parks and things like that are here. Um, and I've been, I'm a developer relations engineer. I've been coding in various languages and doing databases for upwards of 30 years and in a lot of different areas in defense and things like that. And these days, I'm a Gen AI nerd, really. I'm focusing on Python, and I'm just, having fun with all of the Gen AI stuff. Now, to your question, Carter, oh, man, I got to say Marvel. I would say, though, I'm going to start with that, but I'm going to preface it with, when we're talking about the movies, I think Marvel's really done a spectacular job compared to DC. But when we're talking about the comics, bit different. And that's I don't have just a straight up I like this one better or the other. I was always a fan of both. But movies wise, I go for Marvel.
All right, fantastic. Okay, so now we're gonna, and by the way, I'll explain why I'm asking this question later. So I'm gonna turn it over to my friend Alex.
I'm Alec. I'm a Marvel guy. I'm based in Seattle, and I lead our developer ecosystem team, building Gen AI integrations that we'll show you a little bit of in a bit. Over to you, Carter.
Awesome. Thanks. All right. My name is Carter Rabasa. I work with David on the developer relations team here at DataStax. Like Alex, I am located in Seattle, Washington. And the reason I asked the question was because I took my kids to go see Deadpool versus Wolverine this past weekend. So this is sort of top of mind for me. However, I'm going to cheat and say neither. I'm a Dark Horse guy. And then that obviously that's a comment about the comics, right? But it also applies to fantastic movies that have been made based on Dark Horse material. So, sorry, trick question. You're both wrong. The answer is Dark Horse. Okay, so hey, thanks for bearing. By the way, and also if you're in the chat, feel free to share where you're dialing in from. It's always just amazing for us to see all the different places that developers live and kind of and sort of dial in from. I'm sorry that I'm using the word dial in, but I'm 46 years old and I remember modems and stuff. All right, so let's dive into it. We've got that was eight minutes of preamble, and we're gonna dive into code super fast. So this is a RAG 101 talk. So the first thing that's worth talking about is what does RAG even mean, right? So RAG is an acronym, and it stands for Retrieval Augmented Generation. We're going to go into more detail about specifically what this means and specifically how does it work. But I'd like to I like to, when I try to explain RAG to someone who is unfamiliar with it, the way that I explain it is I go backwards. So I say, because just the words in this acronym are not self-explanatory, right? It doesn't really tell you what's happening, right? The way that I think about it is generation is what you get working with an LLM with no tailoring or no prompt engineering, no nothing. It's kind of a ChatGPT style experience where you simply ask an LLM questions, or you ask it to generate something. So it's either generating an answer or generating an image, right? That's what generation means to me. Augmentation is when you're working with an LLM and you're giving it some instructions, right? Like you're actually, and this is sort of like this prompt engineering universe that a lot of people live in, right? Where you're giving it some instructions, you're telling it like what its job is, what the boundaries are, how it should respond, how it should not respond. That is generally how I think of augmentation. And retrieval is basically both of those two things, but where you're actually fetching context and fetching data from some other place. So the augmentation you can think of as static. If you're building an app, like the augmentation could live statically like in your source code, but the retrieval is like, no, like we're getting information, context from somewhere else, perhaps a database, perhaps some other sources. And then in conjunction with the augmentation and in conjunction with the generation, like we're getting some really cool result. So I hope that's helpful. Like I said, we're going to go into way more detail. But that's kind of how I think about RAG, and I kind of think about it backwards. Why RAG, right? Like why are we doing this live stream, and why does anybody care? I won't. You can look at that diagram, but at a super high level, there are just LLMs are arguably one of the most important like technical innovations that have happened in the last 2 years. I mean, I think that's kind of, people can argue about this, but I think it's pretty like it's. I don't think it's very arguable. Like they're one of the most impactful technical innovations that have happened in the last couple of years. However, there are problems, right? Like LLMs. I talked about how you don't need to have learning experience to build AI apps because of RAG. Well, the people who build LLMs have to have machine learning expertise, right? Like LLMs are trained offline on massive amounts of publicly available information. So there are incredibly knowledgeable, experienced people who build all of these LLMs, and there are dozens, maybe even hundreds of LLMs that application developers can build on. But once again, they're trained on this massive corpus of data, and then the training stops. So if you want to build applications that answer questions or can provide like intelligent experiences based on data that the LLM wasn't trained on, like you're kind of out of luck because the LLM simply doesn't have access to that information. This applies to the second bullet point to your business's like proprietary or domain specific information, right? Like whatever app you're building, like you're building a new social network, or you're building a better version of Goodreads, or like you're building a better version of Kayak or something. Your whatever your app, whatever data your app is built on top of, by definition, like the LLMs probably don't have access to that data, right? So they can't. If you want to build an intelligent like assistant or advisor or something that's built on top of your own proprietary data, there's kind of an open question of like how the LLM would even have access to that information to be able to build the better experience for the user. And then this is related to the two things above. Like LLMs just don't have access to real-time information. There are, there's a lot of incredible companies that are building smarter and smarter and smarter LLMs, like OpenAI, Anthropic. I mean, there's a lot of money is being poured into this industry to build more and more capable LLMs that have like more and more updated information. But ultimately, it's not real time. Like even the absolute state of the art best LLMs are simply not going to have access to real time information. So these are problems that application developers have trying to think about like, well, look, like I want to build more intelligent experiences for the users of my applications, but because of these 3 bullet points, like I don't understand how to tie into like the capability, tie like my application into the capabilities of an LLM. And RAG is not a product. You don't go to the Walmart and buy a RAG. RAG is just a technique that Alex and David are gonna show you. It's a technique that application developers can use to help the LLM to provide context for LLMs and help it to sort of provide more relevant and like better answers to questions, or better generation to prompts that users have. So rather than me continuing to talk, I'm going to turn it over to Alex, and he's going to dive into some code examples of like what it looks like to work with an LLM programmatically without RAG, and then what it looks like to work with an LLM programmatically with RAG, so that you get a real grounded experience on like what the difference looks like and like what the benefits are. So I'm going to go ahead and turn it over to Alex.
All right. Cool. So I'm going to show a really basic example of why you need to use of why RAG is valuable. So I kind of made the questionable life decision of buying a old Land Rover, and I use RAG to find replacement parts. So I'm just going to walk you through kind of the code of what life looks like before RAG and after RAG, and all this will be shared, so you can try it after this. So the first step here is we're installing our dependencies. For this example, we're basically using 3 core pieces of tech. Unstructured, which is a popular GenAI ETL tool, right? You need to get kind of your corpus of documents into a vector database. We're using unstructured to do that. We're using LangChain. LangChain is the popular orchestration framework, right? So rather than learning a bunch of different APIs, we interact directly with LangChain, which then kind of calls these APIs in the background. And then we're using OpenAI for the LLM and all our embeddings. So this is pretty basic here. I'm just installing all the dependencies. And here is just a really basic example of what life looks like when you ask the LLM a question without using RAG, right? So at the top, I'm setting up OpenAI, right? I'm plugging in my key, I'm plugging in the model, and I'm just asking OpenAI a really basic automotive question about my car, right? What's the parts number for the tray on top of the dashboard? And you can see right here, the answer doesn't make any sense, right? To provide the correct part number.
Alex, can you zoom in a little bit? Can you make it bigger? Thank you.
There we go. Is that better? Cool. To provide the correct part number, I'll need more information about your vehicle, right? Such as make, model, all that. And that makes sense, right? Because this is just the equivalent of plugging in a question into ChatGPT. ChatGPT knows nothing about you, right? So it's unable to answer very specific questions. So this is where kind of RAG comes in to help ChatGPT gain the necessary context to answer these questions well. So for this RAG example, I'm going to take just a couple basic PDF parts manuals, right? So I have one just kind of manual on like how to fix things. So this is a 1,000-page PDF, right? You can see 864 pages. And then I have another PDF that shows all the parts for the car, all the part numbers, where to buy them, all that. So right here, all I'm doing is downloading these PDFs. Here we can see they've been downloaded on the left-hand sidebar. And this is where it starts getting interesting, right? So now what I'm doing is I'm using unstructured technology to read parse all these PDFs, chunk them, and write them all to AstroDB, right? So unstructured makes it super easy to build these basic pipelines. I set up kind of the files I want it to read. I configure the embedding model, and then I hit run. And a couple minutes later, unstructured has parsed all these documents and written them to AstroDB. So here you can see, now I'm on kind of the AstroDB dashboard. I can scroll down and I can see that unstructured has read all these PDFs, broken all the text into chunks, and written them all to the vector database, right? So I can see something here about removing clips. Here's something about the front axle, but all of this content from these PDFs that I just showed has been read from unstructured and written to the database. This is what we refer to as the data ingestion step in Carter's diagram before, right? In order to do RAG, you somehow need all your documents to be in a vector database like AstroDB. So now that we've done that, here's where it gets super interesting. So here I'm doing some basic configuration of lane chain. I'm setting up the vector store, I'm setting up the embedding model, and I'm doing a basic similarity search, right, in these two lines of code. So I want to take the question, I want to search in my vector store for documents related to that question. And now I'm going to ask the LLM I'm going to enter the same exact prompt, but this time I'm going to include the relevant vector store results. And here, now you can see we get a super accurate answer, right? So the LLM is able to find the exact part number right here and give like a really accurate response. So if I plug that in right here, you can see that it's found this coin tray, right? So previously without RAG, that would mean, scrolling through an 800-page PDF. So you could really see how this could be just like a super efficient way to read your business's PDF or other type of content. Cool. And I will hand it over to David to walk through the next example.
Alrighty, let me go ahead and share my screen.
And then while David is doing that, we had a couple of great questions come up in the chat. Feel free to use I've already migrated some of those questions to the actual Q&A widget. But feel free to ask your questions directly in the Q&A widget. And we'll make sure to run through all of those during the Q&A session. Thanks for the feedback about making things bigger. Hopefully folks were able to kind of like follow along with Alex after he upsized a little bit. And then I made David promise to like zoom in as he's sort of.
Oh yeah, I'll zoom. Don't you worry.
Yeah. No worries. Awesome. Awesome. Cool. So yeah, David, take it away.
Yeah. So what Alex was just showing you a moment ago, a Colab notebook using some Python, things like that, pretty much in raw code, right? You could absolutely do a RAG pipeline that way. Another potential option, though, is to use a tool like Langflow. So this display you're seeing here, this is a free open source tool called Langflow. This is part of DataStax's GenAI stack. Now, what you're seeing here on the screen is, I've got some flows in play and stuff, but what I really want to show you is when you first build up, like you start up Langflow, right? You're going to have like a blank canvas. And Langflow allows you to visually construct GenAI workflows. So a lot of what Alex was just showing you, there's a GenAI flow there, but you kind of have to read the code and understand what's going on. You're limited to Python and so on and so forth. So when I first started Langflow, I might go to something like this new project here in the top right-hand corner, and I can pick from all these various templates. Now, the one that we care about today, right, is this vector store RAG. So what I've done is now I'm purposely zoomed out. I will zoom in just a moment.
And David, not to interrupt your flow, no pun intended. For folks that are watching, like you're showing off a really cool tool. It looks like you're in a browser. Like, how did you install this? Like, how do they? We'll send instructions later, but like, what are we looking at?
Yeah, so Langflow itself is in Python, so this would be like a pip install Langflow kind of thing. So I am running this locally, right? You can see right here. I don't think it's going to zoom that much, but yeah, I am running this locally. You could do it, let's say, with the Docker container. You could deploy it on things like it's on Hugging Face Spaces. You could deploy it to Railway, Render, all sorts of different options from that standpoint. But it is just a pip install, right? At the end of the day, because it is, we are working with Python in this case.
It's cool. And I just wanted to kind of like level set for folks that are watching. So like David's showing off a tool that any one of you could pip install. It's completely open source, completely free, completely vendor agnostic. And then like this sort of like visual editor that you're seeing is a web-based application that's running locally on his computer.
Yes.
Awesome. And then like conversely, what Alex was showing you with our Astra database. That's a hosted serverless database where all of you can sign up for Astra for free, like at no cost as developers. But it is a hosted serverless database that you'd be interacting with. So just wanted to make sure everyone was kind of clear about the difference between these two tools. Sorry, David, I'll let you get back to it.
Yeah, no worries. So from a RAG pipeline, right? What Alex and Carter have been talking about up until this point, we're really seeing that we're seeing that here implemented in this visual flow. So why I'm zoomed out. So this would be the vector RAG template, before modifications or anything. It looks like this. And notice here, there are actually two different flows in here. You have one that I'll call like the generative flow. So when Alex was talking about the data that he was showing you in the database and in structured and things like that, there was some process that was actually iterating through PDFs. It was chunking through the data, storing, converting the relevant meaty parts of the data into vector embeddings, putting it in a version that the GenAI, the LLMs can understand and the vector search can understand, and then storing that in the database. So that's this part of the flow. Now, in this case, in Langflow, I have filled out some of the information. I've actually got a database right over here in Astra. I have a collection called Langflow. So I've filled out some of these details, but the template itself. So if I were to just go, I'm just going to go back real quick. And if I just said vector store RAG, right, it'll create a template that looks just like this. So you already have the logic and the flow of your GenAI, your RAG pipeline already kind of worked out for you. All right, so let me go back here to the one I filled out. And then the top portion here is really the query portion, right? So this is the part where we will take whatever query that we have, and I'm gonna step through all these, by the way, in a second. I'm not gonna just force you all to just understand exactly what's going on, but it allows me to perform some type of query, get the data from my database. So this is a really key part of the RAG portion, right? The retrieval part. So when we're going to augment the generation of our LLM, we need to retrieve some data that we're going to inject into its context, right? And we're going to step through that here in a moment. So this is the portion that you're seeing, right? I'm going to do some retrieval from my vector store, pull that data out. I'm going to inject that into my context. Let's change that to, hopefully I didn't just blow everybody's eyes out of their heads there by changing to the light mode, but hopefully that renders a little better. So here, this context, right? Hopefully you can see that pretty well. This context here in Langflow, this is the part that when I am asking an LLM a question, like if you were in a ChatGPT right now and you actually said, given the above context, and you gave it some context, you could actually start to augment the knowledge of the LLM. We're just doing that with a database here programmatically. All right, so let's back out just a little bit and let's look at some of the components here, right? Because I jumped right into this flow. So you'll notice on the left-hand side, you'll see all these components. So Langflow has all sorts of components that you can use to build flows like this, right? You have some kind of input mechanism, so you can interact with it and talk with it, ask a query. Again, similar if you were in Anthropic or ChatGPT and you're typing something into it. You have a prompt, right, where you can give it instructions. It's essentially what a prompt is doing, right? So I'm going to give some instruction to the LLM on what I want it to do. Now, something I want to point out here is notice these curly braces. Notice how I have this variable in these curly braces. So I have curly brace context, curly brace. And down here, curly brace question, curly brace. Well, a really neat feature of Langflow is if I encapsulate any variable names like that in curly braces, I say check and save, it will then expose those as inputs, right? So what this makes it, what this really does for me as a developer is it makes it super easy for me to just wire up my flow without having to do this programmatically, right? Now, for those of you who are core developers and things like that, you're like, but okay, this is great. This is so cool. I can wire all this stuff up visually, but can I get at the code? Absolutely, right? So underneath the hood of any of these, if I click on one of these components and I go into the little code block part there, it's all Python. Right? This is all Python under the hood. You can modify this stuff. You can make custom components, all sorts of things. I'm not going to delve too far into that because I want to get back to the RAG thing, but I'm kind of using this as a way to just kind of showcase some of the cool things you can do here visually. And this allows you to focus on your GenAI stuff in your RAG pipeline. And then you can wrap your application around the API. All right, so let's go ahead and take a look at first case. What I've done here is similar to what Alex was showing you. I do have a collection, but it's empty. Right? So yes, I have my RAG pipeline hooked up, but if I were to come in, and by the way, in my particular case, I happen to, I'm going to feed it some information here in a second. Let's see. So, kind of going back to what Carter was talking about with RAG in general, if I just go to an LLM, any LLM, and I ask it something open-ended like this, when did I start coding, right? It's not going to know anything about who I am or anything like that. So you can tell by the answer, hey, I'm sorry, I don't have any information about when you started coding. Provide some details or something. So this is like the core of like RAG. This is what I want to get at. So again, my RAG store is empty, right? So what I'm going to do with Langflow is I have fed it a PDF. This PDF just happens to be on my particular career, right? And so we're going to go ahead and I'm just going to run this. Now let's step through what it's actually doing, right? So this is the generative portion. So one, I'm giving it some kind of input. Is it limited to a file? No. You could be a directory. It could be a URL. It could be an API. It could be all sorts of things. Can I control the inputs programmatically? Absolutely, right? So with the API that's available, you can modify these types of inputs. You're not like limited to a single file or something. But for this case, visually, I've just fed it this PDF. Now, what I need to do is I need to iterate through that PDF, right? So I'm going to iterate through it. I'm going to chunk out the data, and then I'm going to essentially go say every 1,000 characters. I'm going to take every 1,000 characters, going to convert those with some embedding model. In this case, I'm using OpenAI embeddings. But something I want to point out about Langflow, and Carter mentioned this earlier, it's model agnostic, right? So if you take a look at all the models here on the left, there's also Ollama support if you have your own local models, right? There's all sorts of ways that you can kind of match things up and use whatever models you want to. Just using OpenAI in here, for example, same thing on the embedding end, right? You'll see there's all sorts of options there. And what's cool is if I want to bring something else in, let's say maybe I wanted to use Mistral or something, I could just drag that over and hook that up, get my key, and go on. All right, so great. So we've iterated through the data that's in the PDF. We're using the OpenAI embedding, text embedding 3 small model, right? And then we're going to store that data in our vector database. And again, Langflow is pretty agnostic when it comes to vector stores, but in this case today we're using AstroDB. So here's what I want to show you. Remember a moment ago, we had an empty collection, right? So what I did is, now if Langflow notices, by the way, that you don't have a collection, at least for AstroDB, it will auto-generate it, but I already had it there. Remember before this was empty, but now I have the data, right? So what's super cool about this is not only do I have the data that I chunked through, but then it's also generating those vector embeddings, the relevant vector embeddings for the data that we chunked. By the way, just let me know, or how's the visibility on this? You guys all able to see this okay?
It's okay. I mean, you can. People always love it when you make it slightly bigger. But I think people are getting the gist of things for the most part. Yeah. And for folks who when especially when Alex was going through his code notebook example, like I'll just remind everybody, like, don't worry, we're going to share the links to the code notebooks. So Don't worry about trying to copy the code from a blurry video. Like we'll have the actual code itself shared out after the live stream.
Awesome. Okay, so I ran, again, I'm doing this all within Langflow. Notice that I'm not actually having to touch any code to do this. This is like the main benefit, right, of using something like Langflow. It allows me to visually build and execute on my GenAI workflows, and in this case, it's a RAG pipeline. So great. So now I've got some data. You can see that the data that we chunked through, right, each one of these chunks of text has been converted into a vector embedding using the text embedding 3 small. That's what we're seeing here in the database. This is the vector coming out of each one of those chunks. And now I have the query portion. So if I pull back a little bit, we're going to zoom into the top here. There's a couple things going on here that are kind of important. One, the question, whatever the query is. In this case, I'm asking, when did I start coding? I'm actually going to go ahead and run this while I'm talking here. Let's do that. So I asked this question, when did I start coding? But I can't just say, when did I start coding, and somehow search that against vector embeddings that are these huge n-dimensional arrays, right? That won't make any sense. So what I need to do is this query also needs to be converted into the same embedding space, if you will. So you'll see again that my search input, I'm wiring this up to my search input of my database, my vector store in this case, AstroDB. But then we also have the same tie-in to the same embedding model. And that's super key, right? Notice that I'm also using text embedding 3 small from OpenAI, the same thing we used down here when I generated the data. And why is that important? Because the different embedding models are going to have, they have different parameters and properties and stuff they're using to encode the semantic data from whatever, in this case, the my text blobs into those vectors that you see. So if I mix and match models, especially from different providers, you're probably not going to get matches, right? So you need to make sure you're using the same one. So again, this chat input is how I'm going to talk to it. It's going to take this particular query. It's going to convert it into the same embedding space as the data that we converted our RAG data into. It's then going to perform a search, right? So here's what's super cool. Remember a moment ago, if I look back at my database, it's not a ton of data in this example, but we do have essentially three chunks of data. Now, I just did a query, when did I start coding? And I did it against the database, but notice it returned one of them, right? So this is actually super cool. And for my particular question, when did I start coding? There are some key things that it was able to pull out. Things like I was around 8 years old, started on a Commodore 64. So the vector search was able, using this essentially the semantic comparison, right? It was able to pull out the relevant results. Somebody asked the question earlier, like, what are some of the benefits of RAG and things like that? Like, well, one of the things, imagine that you have thousands of documents or millions of documents or something like that. It is a lot more cost effective and efficient to go ahead and use something like a vector store to pull out the relevant results and then just put those relevant results into your context. And that's what we're going to do here in a moment. So great, we get a result. Now I just, in this case, if you notice, I have a file path and a text. All I really want is this text. That's what I want to put into my LLM. So I'm going to use this parse data component to pull out the text that you see here. Then here's the real fun one, right? I'm going to take that result from my vector store. I'm going to, again, wiring it right up. Remember those curly braces that I was talking about earlier? We just wire up the output into the context. And now check out what happened. So this is the same prompt we had earlier, but now it's got the context that's been programmatically added to the prompt, right? Along with our question. So yes, this is being done visually, but again, underneath the hood, it's all Python. You have access to this from your application, right? So it is allowing us to build this as we go along. So then when we give the prompt to the LLM, it now has all the information, right? Now, if I come back to the playground, you can see that when I ran that before, it asked the question again, but now instead of saying, hey, I don't know who you are, or I don't have any information about this, it now says, hey, you started coding games on your Commodore 64 when you were around 8. Which is correct, right? It was able to pull that information out of the data that I sent into it. Okay, so I keep talking, by the way, about wrapping your application around this and such like that. So yes, this is implemented in Python. Again, there's code under the hood, but you're not limited to Python at all. And I think this is another really powerful thing about LangFlow. So whether you're using JavaScript, or if you're using Java, or PHP, or whatever, you have all sorts of options here. One, you can treat this as a pure API server, right? You can just call your API endpoint wherever you have LangFlow deployed. You can modify the inputs and outputs and that kind of deal. So you can say, obviously programmatically give it different questions, or you can do a lot more complex examples than this. There is a full, like, if you really want to, I actually find that when I use LangFlow for development, I really like using this kind of flow visually in my testing while I'm iterating, because I can come over here if I wanted to. I could say, something, maybe I want to experiment with Anthropic or something like that, right? I can come in here and I can say, all right, well, I'm going to experiment with Anthropic. I'm going to go ahead and I'm going to wire that up. I'm going to put a new chat output, and I can just do that on the fly, right? So it allows me a lot of flexibility when I'm iterating and going through my code. And then, both Python and JavaScript have, kind of more capable API code that you can put in. But there's a really interesting capability with Python, which is this right here, this from LangFlow load import, that allows you to just import a JSON blob. So any one of these flows, you can export as a JSON blob. And why is that important? Because now, if I want to, I can detach the whole of this logic and embed it directly into my Python app, and I don't need to run this as an API server, right? So it's like a super cool piece of functionality. I've had a lot of people in the past be like, hey, can I just get all the code? Like, can you give me the code or something like that? And while, yes, you can go to the individual components, you can pull out the code and everything like that, the fact that I can just download the whole blob and then import that right into my app means that I don't really need to worry about the individual code if I don't want to, right? I can just get all the logic and everything, put it in my app, and then focus on what my application is doing. All right. So with that, let's see. How are we doing on questions there?
We've got a ton of questions. I think, if you're ready, like, I think we should transition over to Q&A, because we got a ton of great questions.
Let's do it. Yeah.
Okay, awesome. So thanks for providing that run through. Feel free to stop sharing your screen, and we kind of get everyone. All right, let's get everyone back on stage. Let's see.
And by the way, I already see a really good question there at the bottom, but I'll let you do your thing.
No, it's all good. Like, we got a ton of great questions. Awesome. So David, thank you so much for a whirlwind tour of like a really powerful tool for developers, right? There's a ton of questions already about LangFlow that we can start to get into. But we're gonna use the remainder of our time to get through your questions. So feel free to keep adding questions to the Q&A widget, and we're gonna start going through these. The first one that I want to tackle is a really important one, right? Like, why RAG and not fine tuning? It comes up all the time, and it's like, whether you know what fine tuning is, or whether it's just like this word that you've heard, buzzword that you've sort of read on the internet. I basically, fine tuning is the kind of thing that you do if you actually have like machine learning engineering expertise. right? Like if you're a machine learning engineer or you work on a machine learning engineering team, yeah, like you might have this skill set and the desire and the inclination to either build your own LLM, or to take an LLM and to fine tune it. For folks who don't know what I'm talking about, the simplest explanation is like fine tuning is taking an LLM and then sort of tuning it to provide like optimizations around the kinds of questions that you want to be able to answer for the app that you are building. The simplest thing that I can say is that RAG is a fantastic technique and tool for developers that don't have machine learning expertise, or don't want to take the time, because fine tuning is a very incredibly like labor, capital, time intensive process. Like you could spend weeks or months fine tuning a model based on whatever your domain information is. RAG is something that any full stack web developer can implement in like a day or a weekend, at least like as a prototype, right? There's always a little bit more work that is required to ship something to production, but that's probably arguably one of the main benefits of RAG. It doesn't require that kind of domain expertise. It's very fast to implement and it's very low cost to implement. Alex or David, do you have any other anything you want to kind of add on there?
No, agreed on the cost comment, right? It's significantly less expensive to play around with RAG and fine tuning. So definitely plus one on that point.
Yeah. Yeah, I mean, there are use cases where fine tuning is the correct decision, but like all engineering decisions, it's just about trade-offs. It's like, how fast are you trying to come to market? What technical expertise do you have at your company? Like, what are you trying to achieve? Like, how much are you willing to spend? Those kinds of things. David, you said that you kind of identified a question immediately that you wanted to dive into. Which one was that?
Oh yeah, it is. Delante Lee Best said, "Wow, can you experiment with multiple GPTs at the same time?" Yes, absolutely. In Langflow, as a matter of fact, I have a totally separate app from what we're talking about here that does real-time language translation, and it has 4 different LLMs being used because, and that wasn't just like a showcase thing. That was actually for what I was doing in that particular app. Different LLMs are actually really good at different things. Some are great at language translation. Some are great at code. Some are great. It depends. So yes, that's actually, I think, one of my favorite features of Langflow is the ability to just very quickly, you can just drag and drop them. You go get a key from the provider, pop in your key, and wire it up, right? And you're done in 30 seconds or something.
One thing I wanted to add very briefly, a question came up. I don't know if it's in this list or not. Right? Someone just asked, like very plainly, like why would I use this instead of LangChain? I think one of the ways that I think about it, like much of Langflow is built on top of LangChain. Like if you're comfortable with LangChain, if you're familiar with LangChain, like I think that you'll be really comfortable and familiar with using Langflow. Because a lot of what Langflow is sort of this GUI built on top of these LangChain components and primitives. One of the reasons you might do it though is that LangChain is a pretty vast, like people call it a Swiss Army knife. Like there are like just thousands of different like LangChain methods. Langflow is highly curated, right? So like Langflow is a subset of like the universe of functionality that LangChain has. And it's curated with an optimization towards RAG applications and an optimizations towards like using the parts of LangChain that are actually like up to date, that aren't broken. So if you're, even if you're familiar with LangChain, like you might, I would definitely ask you to check out Langflow to see if it's missing anything that you actually like use all the time from LangChain. So I just sort of think of it as like an opinionated, curated tool that developers can use to build these AI flows. And also, it is because it's built on top of LangChain. If you want to use things like which is LangChain's observability service, you just get it for free. Like you build your AI flow using Langflow. You flip on an environment variable for your Langsmith key, and it just works with no extra added effort on your part.
And so I'd like to add to that, Carter. With using LangChain compared to Langflow, conceptually, like if you're the person who's in the code and you understand the LangChain libraries and what's actually going on in the code logic, that that's wonderful. But conceptually, especially as some of the workflows become more complex, they are much easier to visualize, like conceptualize, when you can see them visually. And not only that, it's much easier to then present them to somebody else, right? And say, hey, this is what this flow is doing, and here's how the individual components can work. Could you do that in LangChain? Absolutely, right? But especially if you're showing it to somebody who might be a non-coder or want their involvement, then that's almost a non-starter, where when you see it visually, it just makes it so much easier. I find that in my own personal development, it's just easier to reference because I can take a look at it and I can see exactly what's going on in my flow.
Next, we're gonna fire through these because there's so many really great ones. I was actually hoping Alex could maybe take a stab at this one. It's a really reasonable question where the developer is like, look, like I want to do RAG, I want to do vector search, but I have other like criteria or like other attributes that like I want to factor into how these things are sorted, or how I build the query. Like Alex, do you have any thoughts for like what they could do?
This is this concept of like hybrid search, right? Where you're doing a vector search and you're also filtering on certain columns. So maybe if you're a grocery store, right? Like in your database table, you'd have your vector embeddings, then maybe like, produce and chips. And there's this concept of hybrid search where you could essentially like filter to only search, your produce items and then kind of look for and then do the similarity search. So that would be my recommendation, and that's fully supported in AstroDB.
Yeah. I think look, developers have a lot of choice when it comes to vector databases and vector search. The two, we don't have time to go into all of it. The two broad categories of like databases you're going to hear about are pretty much like vector only databases that just they store vectors and they do vector search, and that's pretty much what they're built and optimized for. And then there are fully fledged application databases that also support vector storage and vector search. So AstroDB is in the latter category of database. And as a developer, what that buys you is the ability to do what Alex said, which is basically hybrid search. So you can think of it as you're executing this filter, you're executing this sort, you're returning documents and you're sorting them, but you can sort by multiple fields. One of those fields could be the vector field, the vector similarity field, but then the other could be these other attributes that you want to sort on or that you want to filter for. And that's something that Astro makes it really easy to execute that kind of hybrid search. So that's one way that you could do that. All right, David, a question for you about chunking. This comes up all the time. This is for Alex and David, right? I mean, like,
yeah.
How should develop, like, once again, this is a RAG 101 talk, like we don't need to go into crazy depths of detail, but just like really high level, like how should an application developer think about what their options are for chunking, or like just stuff that they should consider when they're chunking in order to sort of improve the results of their application?
Yeah, I've got a couple things to say about that. One, if you're talking about just pure chunking, part of that is going to be dependent on the embedding model that you're using. So I would look at that, right? There's going to be slight differences between if you're using like NVIDIA's NeMo compared to OpenAI's text embedding models or Mistral or whatever, right? So it does take sometimes a little bit of research on the individual models, and honestly, you should experiment with them anyway and kind of see what works for you. But you'll find that for each of the individual models, they will have slightly different chunking strategies. But the other thing, and I see Alex, you also posted the link. I'll say something real quick. The other thing is there are whole different methodologies. Like there's something called Colbert, where it's a completely different way of doing it. It's not just grabbing, like in the example that I showed, it was just kind of doing this generic, I'm going to grab 1,000 characters, right? And it doesn't matter what's in the text. It doesn't matter if it's semantically similar or anything. I'm just going to grab, 1,000 characters and I'm going to chunk on it. Colbert is a different method that is actually a bit smarter when it comes to context. And it doesn't actually do chunking in the same way at all. It actually is based off of tokens. And you're saying, hey, I'm going to grab a set of tokens, but then I'm going to get information about the surrounding tokens. I'm going to vectorize that with a smaller, essentially smaller dimension amount, like 128. But then I'm also going to set up something that allows me to slide and like kind of overlap data on purpose. It's actually very good for maintaining context and everything. So it's a totally different strategy than just straight up chunking. Yeah, so there's definitely multiple ways to do it. I think experimentation, a little bit of research on the models you're using goes a long way there.
Yeah, Alex, you have anything to add there?
I was just going to add, we heavily use this lane chain recursive text splitter. So might be interesting to take a look. They have some good docs with recommendations on chunk size and overlap. We also heavily use the unstructured for text splitting, chunking. So they all have super good resources. And we're also about to ship a blog, or we did ship a blog on chunking that we'll share after this as well. With some thoughts.
Yeah,
recommendations.
And I'll just say this, like super high level stuff, right? Like all developers, application developers that are starting to get into generative AI and RAG, like you might find this frustrating, but the amount of time you spend writing code is going to be a lot less than the amount of time you spend like experimenting with these different things. Right?
Yes.
David talked about swapping in and out LLMs. Yes. We just talked about like different chunking strategies and try this. And like I think it's frustrating for some developers who are accustomed to thinking of their productivity based on the number of lines of code that they're kind of writing per day. But AI engineering is oftentimes more about like iterating, right? It's more about trying different things, looking at the results, tweaking some of those parameters, and then trying it again. This is true for prompt engineering, true for chunking, true for LLM choices. And frankly, I think it's overall a good thing, right? I mean, like, it's definitely less about like writing code and more about like understanding how to like integrate these different tools and optimize the results for developers. Someone asked a really great question about the embedding part, right? And there's a bunch of really cool stuff that we're doing to like make this part easier. I thought Alex could maybe dive in a little bit.
Yeah. So, can you explain? So the question is, can you please explain the embedding part in more detail? So basically, in order to perform a vector search, you first need to take kind of your document corpus and convert it into vector embeddings, which are basically just arrays of numbers. So basically how you do that is you call an external API. In my example, I used OpenAI. OpenAI will take that raw text, convert it into this array of numbers, and then you store it in a vector database like Astra. So we recently introduced this feature called Vectorize to make this entire process easier. So rather than kind of playing around with a bunch of external APIs, you can now use the ActualDB Vectorize API with a single API call, embed your data, and also write to the DB. So we can share more information on that. It's also super easy to embed your content with link flow that David showed a bit as well. Is there a way to, and this is a question that's came in that's relevant, is there a way to find out the quality of embeddings? Like, how do we know embedding is good or not? There's a bunch of rankings online on like the best embedding models that you can take a look at. If you will just like embedding model ranking, Hugging Face is a really good list.
Yeah, and I think another recommendation that I've seen people implement and I think yield good results, like as developers, like we're totally accustomed to writing unit tests and like writing integration tests. Like you're basically going to do the same thing for these applications, right? Like you can build a test harness and a test suite that has a bunch of expected questions or expected prompts. And then you can run those prompts through your application, and you can actually use an LLM, and you can have like an expected output, and you can actually use LLMs to compare the actual output to the expected output. So even if it isn't character, that's cool. Even if it isn't even if it isn't character for character identical, like you can ask the LLM, like, hey, like is this like 90% similar, right? And I've seen people do that. And you're going to want to do that because once again, like, think, why do we have unit tests? Like, right, we have unit tests because like you're constantly iterating on your application, making changes. And you have to have confidence that when you make changes before you ship the changes to production, you haven't created a regression or broken everything. So this is AI engineering is just it's taking a lot of things that we're used to, but changing them into sort of a new form of those things, like for for this generative AI age that we're in. I wanted to get to this
Yeah.
question because it's sorry, because we're running low on time. Because I think this is important, right? Like this person's asking, like, hey, like, how do we think about the R part of things? Like, how do we think about leaking confidential information to LLMs? Very quick comment from me. There are two kinds of LLMs that you can use. There are open source LLMs and there are sort of closed source, like service LLMs. Think of OpenAI as like an example of that, right? If you're using an open source LLM, you don't need to worry about your data or your company's data or your customers' data being leaked to anywhere, right? And that might be a consideration that you make when you're trying to decide what LLM to use. But conversely, like if you want to use a service-based LLM, you simply, like every other API or every other service or every other database that you might think of using for sensitive customer information, you're going to have to pay attention to the sort of the terms of use and the terms of service, right? So in the same way that you might ask the question, like, where can I store sensitive and customer data, like ask those exact same questions in terms of the LLM services that you might use. So for instance, Astra, Alex, did you talk about Vectorize as part of Astra yet?
Yeah.
Awesome. So as Alex mentioned, like, we natively support a bunch of providers and embedding models in Astra DB. And we support both OpenAI and Azure OpenAI. So for developers that build as part of Microsoft and Azure's ecosystem and sort of have a preference for storing data and using APIs that are part of that ecosystem, like we support Azure OpenAI. But that's something that you would just sort of need to pay attention to as you're building these applications. Cool. So we're running low on time. I wanted to kind of maybe close with this, right? And I'll pop this up, right? Because I'm sorry we can't get to everything, but these questions have been awesome, right? And I think this is a good one to close with, right? Like, and I'll pose it to both David and Alex, right? Like, what's like the one or two sentence like explanation or just analogy that like you could use to explain RAG to, I don't know, people always use the stereotype of like your mom, but I think that's kind of like, let's not be mean to moms in the world, right? Maybe your kid, right? Like, like what is, like, how would you sort of describe it? I'll go first, right? I don't know if this is the best analogy, right? But there's our chief product officer here at DataStax. He has to do a lot of he has to have a lot of meetings and do a lot of interviews with like analysts and journalists. And there's sort of a game that gets played where because people can ask like any kind of question and you have to have like information like available like on hand to be able to intelligently answer those questions, because you just never know what an analyst or a journalist is going to throw at you. And there are assistants, like there are people that work with Ed, our chief product officer, that like have that data like at their fingertips and they can sort of provide it to Ed so that he can sort of answer the question with enough context to like help the analyst or help the journalist sort of understand what the answer is. And I think that's kind of like a decent sort of metaphor for how RAG works, right? Where like the question or the prompt is just unknown in advance. But like you can use that question, that prompt to sort of like very quickly and efficiently like get some context and some information, and then you provide it to someone like Ed or someone else that like can sort of take that context alongside the original question and provide like a really great, like easy to understand answer for the person who asked the question in the first place. So it's like, I don't know, that's one thing that kind of came to mind for me. But David, I'm curious if you've got something better.
Oh, I don't know. I'm actually laughing at Hugh Brown's comment there. It's, as you can tell, it's actually really hard. This is hard one to put in a short explanation. But yeah, I would say it's almost like having, your business domain expert following you around, right? Because the way I usually explain it in terms of domains, whether it's my personal domain or my business domain, the LLMs just aren't trained on that. right? So it's like you've got your little business domain expert who's following you around, and so when somebody asks a question, they can immediately inject that context. Very similar to what Carter was saying, honestly. But that's my shot at it. I don't know.
And I will put Alex. I'm not going to put Alex on. Alex, do you have like a pithy sort of like fun analogy?
I can't come up with anything
Should we
better.
ask ChatGPT for one?
Don't want to disappoint you. So
No,
that was great.
No worries. But look, I guess the other thing that I'll say, as we kind of close this out, like actually, it's not really an analogy. I think it's like a fact. Like if you are a full stack developer, right, and you have been writing, SQL queries or like no SQL queries for the better part of several years or several decades, building full stack web applications, like honestly, that's all this is, right? Like if you know how to build a CRUD app where like, the user shows up to your app and it wants to view the detailed description for some book that's in like your book database, and like how to do the select query, or how to do the NoSQL query. Like if you know how to build CRUD applications, I just think that you'll be super comfortable with RAG, right? Because that's what it is, right? Like RAG is just sort of like the nuanced difference is that like when you build these CRUD applications, usually you have these like fixed properties or fixed columns, and you're kind of composing a SQL query with a where clause, right? Select from books where ID equals X, right? So that's what CRUD applications are. And really just RAG applications are like this really slight nuance where it's like, hey, like get all the documents like where the question matches the vector, right? But like conceptually, like that's really what you're doing. And then there's a little bit of detail on the other end. But I think if you're a full stack application developer and you're comfortable with CRUD, I think you'll be really comfortable with RAG. You'll certainly be more comfortable with RAG than you would be with fine tuning or some of the other techniques that require like radically different like domain expertise and knowledge. Okay, well, we're 2 minutes over.
I do think I have a concise one. It's having a natural conversation with your data, right? Like, because everything you were just talking about, like for decades, we've had to, learn how to write SQL or do keywords or find all these different ways we can get at the data. But now you can literally just have a natural conversation with your data. That's my take now.
I think that's awesome, and that's a perfect way to end it. So we're a couple minutes over, but thanks for sticking around, everybody. This is super fun. We're going to do a lot more of these things. Thanks for all the awesome questions. Thank you so much to David, and thank you so much to Alex for joining us. Once again, this is all being recorded. We're going to post it. It'll be online. It'll be available immediately after this is over. You can share it with your friends and colleagues. And we'll hopefully we'll see you all soon for our next stream. So until then, take care, everybody. See you later.
Thank y'all. See ya.